area of force vectors, and specifically we're speaking about today position vectors and force vector directed along a line. So what I'm going to do here is basically represent a position vector in Cartesian coordinate form from the given geometry, and then also represent a force vector that is directed along a line. Okay, so in the picture you see here, we have this big ship. In this big ship, they have these ropes. These are called mooring lines, and it's connected to the bow of the ship. So these mooring lines connected to the ship can be represented as a Cartesian vector, right? As a Cartesian vector. The questions that we're interested in are maybe what are the forces in the mooring line, and also how do we find the directions of these forces within the mooring lines here, right? And then why would we want to know these things, right? Start thinking about things like that. Why would we want to know these things? Okay, so let's take a look at this first piece. And we're looking at position vector here. Okay, so a position vector is basically defined as, so it's defined as a fixed vector that locates a point in space relative to another point. So a position vector is defined as a fixed vector that locates a point in space relative to another point. So if you consider, let's consider 2 points, right? Points A and B. And consider these points in 3D space. So we let their coordinates be x sub A, y sub A, z sub A, and we'll also say x sub B, y sub B, and z sub B, respectively. So the position vector, that position vector, this is going to be directed from A to B. So it's directed from A to B. So this is R sub AB. So R sub AB is defined as such. X sub B minus X sub A I, Y sub B minus Y sub A J, and then Z sub B minus Z sub A K. So just please note that B is the ending point, right? And that A is going to be the starting point. So what you're to do is always subtract tail coordinates from the tip coordinates. Subtract tail from tip. So again, always subtract the tail coordinates from the tip coordinates. So very important. Let's take a look at a force vector directed along a line. Then we can represent the force vector in Cartesian coordinates by using a unit vector and the force's magnitude. So to do this, here's what we need to do. Find the position vector r sub AB along 2 points on that line. 2 points on that line. Find the unit vector describing the line's direction. So we have u sub AB is equal to r sub AB, and this is over r sub AB. So the r sub AB in the numerator is the position vector. Unit vector by the magnitude of the force. We're given that the 420 Newton force is along the cable AC, So what we're told to do is find the force F sub AC in the Cartesian vector form. Is to go ahead and find the position vector, right, which is r sub AC, and then find its unit vector, u sub AC, and then we'll obtain the force vector as F sub AC equals 420 newtons u sub AC. All right, so looking at the figure, when relating A to C, after looking at this figure relating A to C, looks like we're going to have to go 2 meters in the x direction, right? 2 meters in the x direction. Looks to be 3 meters in the y direction and -6 meters in the z direction, right? When we relate this A to C. 2 meters in the x direction, 3 meters in the y direction, and -6 meters in the z direction. So therefore, we have r sub AC. For us, this is going to be 2I plus 3J minus 6K. And this is in meters. All right, and we can also find r sub AC by subtracting the coordinates of A from the coordinates of C. Sub AC is equal to 2 squared plus 3 squared plus a -6 squared, all raised to the 1/2 power, right? Meaning we're taking the square root of all of that. And is equal to, the calculation should be 7 meters. All right, so now U sub AC, right? We say that's R. If you recall from earlier, just go back in the video and see what we're talking about here. And then F sub AC. So that was the 420 U sub AC. Okay, so then that's gonna equal for us 420 R sub AC over R sub AC. So therefore F sub AC is going to be the 420, and then we'll take the 2I plus 3J plus -6. Sorry, I should just written -6K instead of plus, but it's fine. And that's over 7. This is in newtons. And then that's going to get us 120i plus 180j minus 360. Okay. All right, and this is